So I just quickly want to go through a demonstration of looking at a different shape and doing the same process we're expecting to do with quadrilaterals, with triangles. But this stage, instead of the previous demonstration, we looked at counting squares. We said, let's have a look at the triangle shape on the screen. We've got 1, 2, 3, 4 whole squares, 5, 6, maybe 7, 8 whole squares, and then tried to round up the other and work out the area by counting squares. This time I want to use a rule, and I apologise for some reason my webcam's not working, but we'll keep going. So we've got a triangle. So I'm going to use the same process as you use for quadrilaterals for this. So what I'm going to do is I'm going to put a dot halfway along each side as how we're going to cut these shapes in half. So this first one is 1, 2, 3, 4, 5, 6. So a halfway dot is going to be right there. Right. So it looks like a nice shaped dot. So let's just copy that a couple of times. Okay, now on this side it goes up 1, 2, 3, 4. So halfway is going to be at the point at which that side has gone up to. Pop that in there, that's halfway there. Pop that in there, and that's halfway there. So all we've done is we've put a dot halfway along each side, exactly what you do with the quadrilaterals. The next thing we're going to do is I'm going to now join those dots. Right, so one join goes here, pretty happy with that. And we've got a couple of more dots to join. That one starts there and goes down to here. So the inside triangle, probably not surprising because you've got 3 dots. So you're joining 3 dots, you're expecting to make a triangle. That one there, and this comes down to here. Right. So you could look at this inside one. So there's 2 whole ones, and there's probably another, maybe 2 half ones. Maybe it's going to be 4 altogether. Not the greatest triangle. Let's see if I can just tidy that up a touch. Okay, but instead of that, we're going to use the rule. So the rule for finding a is half times the base times the perpendicular height. And you'll see that another way. So the most common other way is base times height divided by 2, but it means the same thing. So let's go about how we can do this without counting the squares. Right. So let's have a look at the big one. I've got a ruler here. Right, so you can't see the rule, you just have to trust me. It'll be different on my screen to yours. But the base is 5 centimeters. So base is 5 centimeters. The height of the triangle, so the height goes from the bottom. Perpendicular height means a height at 90 degrees. So you look at the highest point of the triangle, work out where it meets at 90 degrees to the base, and you measure that. So it's going to be 2.5. So perpendicular height 2.5 centimeters. So the area, we've already got the rules, so it's going to be 1/2 times 5 times 2.5. I'm going to put this into Excel as a sum. So half is 0.5 times 5 times 2.5 equals 6.25 centimeters squared. So that's the big area of the shape, 6.25 centimeters squared. And I'd love to see you guys setting it out that way, right? Don't just assume that we know what it's going to look like. So now the inside triangle. So we're going to measure these things again. Right, so the first thing we do is measure what becomes the base of the triangle across here. The base is going to be 2.5 centimeters. The height is going to be from the highest point of the triangle to the base at 90 degrees. So even though it's like upside down, this is still going to be the easiest way to do. So it's going to be about 1.2 centimeters. Okay. So the area, got the rule there. It's going to be 1/2 times 2.5 times 1.2. And let's put those numbers in. You would probably use a calculator for this, but I like using Excel for my calculations. 0.5 times 2.5 times 1.2 equals 1.5 centimeters squared. Maths teachers are always a bit fussy about units. Make sure you get the centimetres squared in there. And now we want to go back to our conjecture, which is here. When we put dots halfway along each side of a triangle, the resulting triangle has an area 1/3 of the original triangle. Well, it doesn't look like this, okay, because the original triangle 6.25, so 1/3 of that would be like a little bit over 2 centimetres squared. It's 1.5, so that would seem to be a counterexample. We can see how much bigger the first one is than the second by saying, okay, it's going to be 6.25 divided by 1.5. So it's going to be around 4 times bigger. So that would show that that conjecture is not right. When you do your conjecture, most of the ones around quadrilaterals have been saying well, the inside shape is half the outside shape. Don't be shy about just making a simple conjecture like that and testing it. So that's an example of doing rather than a quadrilateral, I've used a triangle, but I've used the same process as dots halfway along, joined the dots up, calculated the area of the outside triangle, but instead of using just grid paper, I've used a rule to help me here, and the area of the inside triangle.